All right, let's get right into it. We're not just talking about some old scientific argument here. We're talking about a heavyweight championship for the very nature of reality itself. This was a clash of titans, a battle of ideas that completely reshaped how we understand the universe.
So, in this corner, you've got Albert Einstein, the man who literally rewrote the laws of space and time. And in the other corner, Niels Bohr, one of the founding fathers of the bizarre new world of quantum mechanics. And right in the middle of their epic debate is a cat. A very, very famous cat that represents the whole paradox at the heart of their disagreement.
So let's set the scene. Just picture it. Two of the greatest minds in history, maybe meeting up somewhere beyond our world, to finally, once and for all, settle the argument that defined their entire lives. How does the universe really work?
And this really gets to the core of it. On one side, you have Einstein's universe. It's like a perfect, intricate Swiss watch. He was absolutely convinced that underneath all the chaos, there was a beautiful, predictable order. But Bohr, on the other side, was staring at evidence that pointed to a totally different reality. A universe that runs on pure chance, probability, and a level of weirdness that just defies all common sense.
You know, it's pretty wild when you stop and think about it. These two men were behind the two theories that completely defined physics in the 20th century. They were friends, they were colleagues, and they were the fiercest intellectual rivals you could imagine.
Okay, so check this out. Einstein's theory of relativity, that's the rule book for the very, very big. Planets, stars, galaxies, the whole cosmic dance. It's elegant and precise. But then you've got quantum theory, Bohr's domain. That's the rulebook for the super, super small, atoms and electrons. And here's the massive problem. The rules that work perfectly for the big stuff completely, utterly fall apart when you get down to the small stuff.
Okay, so this is where you might want to buckle up because things are about to get really, really strange. The first big break from what we think of as normal, classical physics was a concept that seems to make no logical sense at all. So, let me ask you, what is an electron? Is it a tiny, solid little particle like a microscopic billiard ball? Or is it more like a ripple spreading out in a pond, a wave? For centuries, that was an easy question. Things were one or the other. But quantum mechanics, well, it came back with a very different answer. And the answer it came up with was, what? It's both, at the exact same time. According to Niels Bohr and his colleagues, an electron isn't just a single point in space. No, it exists as a wave of possibilities, which means it's literally smeared out, with a chance of being here or there or anywhere else all at once. And here is the part that completely broke Einstein's brain. That electron only acts like a wave when you're not looking at it. The very instant you try to measure it to pinpoint its location, poof, that whole wave of possibility just collapses into a single particle at a single spot. And for Einstein, this was just madness. He was like, no way. An object has to be somewhere. It has to be real, whether I'm looking at it or not.
So this idea that our observation doesn't just see reality but actually creates it, well, that opened up an even bigger philosophical divide. It became a battle between a universe of certainty and one governed by random chance. What this all means is that, at its very foundation, quantum mechanics says the universe is fundamentally unpredictable. We can never know for sure where that electron is going to show up. All we can do is calculate the odds. It's like physics suddenly turned into a cosmic casino. And Einstein, he hated this. He absolutely could not accept it. This is when he famously wrote in a letter, "God does not play dice with the universe." To him, all this randomness and probability wasn't a feature of reality. It was a flaw in our theory, proof that we were missing something deeper.
So, to really drive home just how absurd he thought all of this was, Einstein's friend, Erwin Schrödinger, cooked up what is now probably the most famous thought experiment in the history of science. It was designed to take this quantum weirdness out of the atomic world and bring it into ours. So, follow me on this, because it's a strange setup. You put a single radioactive atom in a box. It has exactly a 50-50 chance of decaying in the next hour. If it decays, it triggers a Geiger counter, which releases a hammer, which smashes a vial of poison, which, well, you get the idea. And sitting inside this box with this whole deadly Rube Goldberg machine is a cat. The poor cat's fate is now tied directly to a random quantum event.
All right, so here it is, the million-dollar question. After that hour has passed, but before we open the box to check, is the cat inside alive or is it dead? Now, common sense. Einstein's sense, would say, duh, it's one or the other, we just don't know which one yet. But that is not the quantum answer. Oh no. According to the bizarre rules of quantum mechanics, since the atom is in a superposition of both decayed and not decayed, the cat must be in a superposition too. Which means the cat is somehow both 100% alive and 100% dead at the exact same time.
Yeah, just let that sink in for a second. In the quantum view that Bohr defended, the cat's fate is genuinely undecided. It's not one or the other until we look. The moment we open the box, we force reality to choose a state. Our act of looking doesn't just reveal reality, it actually creates it.
And look, this wasn't just some historical argument they had over tea. Einstein and Bohr went at it for decades. And the most incredible part is, the argument still isn't fully settled. This debate points to the deepest, most fundamental mysteries that physicists are still wrestling with today.
So what are we supposed to take away from this whole cosmic showdown? Well, a few huge things. 1, reality at the smallest scales just does not care about our intuition. 2, this idea of superposition, of existing in multiple states at once, is very real. And 3, maybe the most profound takeaway of all, is that the universe seems to run on probability. And the simple act of looking at something is a far bigger and stranger deal than anyone ever imagined.
You know, a frustrated Einstein once asked a colleague, "Do you really believe the moon exists only when you look at it?" He meant it to be a ridiculous, self-evidently absurd question. But after a century of grappling with quantum mechanics, physicists are still not 100% sure they know the answer. And that is a thought to keep you up at night.